Good afternoon, and once again welcome to my YouTube channel, Pearson Edexcel International Maths by Mr. Kamotho. And in this video, we want to continue explaining integration, and today we'll be looking at example 11 of a topic called integration in Pure Mathematics book, in Pure Mathematics 4. And we have been talking about a subtopic that is called integration by parts. And we know one rule: integration by parts, it's always in this format. When you're supposed to integrate u dv dx, what you need to do is you have to have u, you have to have v minus the integral of v du dx with respect to x. Of course, we know what that means. And in this setup, we have an integral of two terms, x squared e raised to power x with respect to x. So it is up to us to realize or to separate the variables so that we can integrate by parts. Now we have two terms. What do we take u to be, and what do we take dv dx to be? Obviously, anytime you are having e raised to power x, let that be dv dx. So it goes without saying that u is x squared, and if u is x squared, because at some point we are going to use du dx, then du dx becomes 2x. And if that is now u, then e raised to power x is dv dx is e raised to power x. And because we have been dealing with exponential raised to power variable, and we have always known that the dv dx, if we have e raised to power x, then the v, after integrating this, becomes the same thing. Because even when we are having ex, the differential of ex is the same e raised to power x. And if that is true, then we need to pick the u and the v and substitute them here. So we are going to have x squared ex minus now the integral of v, which is e raised to power x, du dx, which is 2x with respect to x. And it follows that even the part that we have now realized, it dawns to us that the integral part is still having two parts. And therefore, we still need to integrate this part by part again. We still have to find u here and dv dx there, so that we can actually do exactly what we did previously. And at that point, at this point now, dealing with this, then it's going to give us u is equals to 2x, and if that is true, then du dx is going to be 2, and dv dx is going to be ex, and obviously v becomes the same exponential raised to power x. Substituting now uv, this part at least to have a format that is resembling that one. This part is finalized, so we have x squared ex minus open bracket now, because we are subtracting the whole thing. uv, what is u? 2x, and v e raised to power x minus the integral of v du dx e raised to power x, and du dx is simply 2. What we have here is we now need to open this bracket. Opening the bracket is easy, so we have x squared e raised to power x minus 2x e raised to power x, and because of this negative and this negative, and the 2 is a coefficient which should actually be positioned. It can also be positioned here, so that we don't bother looking for the integral of 2. We only bother to look for the integral of ex, which is ex. So, but this negative and this negative becomes a plus 2 e raised to power x. And because entirely we've been dealing with infinite integration, then we have to introduce a constant c. And that is just like it, unless you would want to highlight what is common in the first three terms. EX is common there, EX is common there, and EX is also appearing there. So you may have e raised to power x, open bracket, x squared minus 2x plus 2, close bracket, of course, plus the final constant c. And at the end of the day, that would be the final submission to that particular question. Please note, we were able to integrate by parts twice or in 2 levels due to the fact that even the integral that we realized after integrating in the first level, it was not finalized to one time. So we had to do it twice, and that is why we have realized now this particular setup. And that is the final setup. Either this format or this format is quite good. So there you go, and there you are. Once again, I continue to ask you to subscribe widely. Of course, share this YouTube channel widely, and let us work together through this journey of mathematics. Otherwise, thank you and see you in the next video. Thank you.